some fundamentals of mass transfer. What is the mass transfer? Mass transfer is the process in which the molecules or the mass is transferred from a region of higher concentration to a region of lower concentration. Or you can say mass is transferred from one point to another point due to concentration gradient, that is delta C. Okay, so this is the delta C. Now let's take this picture as an example. Okay, and the mass transfer is due to the diffusion. Okay, so what happened in diffusion? This, let's consider this is as system A and this is as a system B. Okay, so for system A, it is enriched in the molecules having green color. Okay, this green color, and the system B having the molecules. System B contains both the red and the green molecules. Okay, so what happened? As from the definition, it says that mass is transferred from a region of a higher concentration to a region of a lower concentration. Here in system A, the green molecules have higher concentration. Okay, but in system B, it have the low concentration. What will happen when we remove this barrier? So what will happen? The molecule start transferring from system A to system B, because in system B they have the lower concentration. So they will travel in this direction towards the system B. Okay, so that is what definition is saying about the mass transfer, and hence the mass transfer occurs, which is due to the diffusion. And the driving force for the mass transfer is concentration gradient, which is delta C. Mass transfer operations depend upon the molecules diffusing, vaporizing from one distinct phase to another, and are based on difference in vapor pressures, solubility, and diffusivity. We use these terms depending upon the mass transfer application that we are dealing with. Okay, so if we are dealing with the what we can say vapor phases, vapor gases, and gas to liquid mass transfer, and liquid to gas mass transfer, we usually use the vapor pressure, and there is a relation that shows a relation between the concentration and the vapor pressure. Okay, so now let's consider this picture. So this is the, let's say this is the system is the system contains red molecules. Okay, at time t is equals to 0, means initially, and when we pour some green molecules in this same system, the system will look like this. Okay, the system at that time will look like this, and after leaving this system for a certain time, like maybe 5 minutes, 10 minutes, 1 hour, okay, after that you will see the system will appear like this. All the molecules, all the green molecules will occupy all the spaces in the system. Okay, so the system will be enriched in the molecules having green colors. Okay, and that is due to the diffusion. So molecules are diffusing from here to here, from here to here, and occupying the space. Okay, like this the diffusion occurs. So the diffusion is due to the molecular mass transfer, and the molecular mass transfer is due to the random motion of the molecules. Okay, remember we are talking about just random motion of the molecules, and we are not taking any external force that is applied on the system. Okay, so there are no turbulent effects. Okay, we are not applying any mechanical force. It's totally and purely due to the molecular diffusion at normal standard conditions. Okay, so here you can see we are now here we are uh, putting the ink. Okay, this drop of ink goes, and the system will initially look like this. Okay, so here the ink have the higher concentration, but here the at this location the ink's molecule having the lower concentration, so they start traveling here and there. So molecule are diffusing here and there until they reach an equilibrium. Okay, after some time the system will look like this. It is almost occupy 50% of the system. Okay, further leaving for some times, you will see the final system look like this. Okay, So all molecules are diffuses in the system. Okay, now equilibrium is achieved. The final system will look like this. Okay, that is what we call the transfer of mass from one phase, from one point to another point, and this is due to the concentration gradient. Okay, there are two things that we need to consider when we are talking about single phase and when we are talking about the interphase. Interphase means two phases. Okay, when we are talking about the mass transfer between the single phases, so we usually says like the mass transfer is due to the concentration difference. That is the standard word to be used for the single phase. And for the two phase and the interphase mass transfer, then appropriate term is we need to say like mass transfer is due to the chemical potential. Okay, this is like the gradient for the mass transfer. These are inappropriate words for defining the system. Okay, so this was about the diffusion. Now, rate of mass transfer. Okay, the rate of mass transfer depend upon we know the turbulence and all these things. Okay, the more the turbulence, the more the rate of mass transfer, the more the rate of heat transfer. Okay, like this. But for now we are talking rate of mass transfer depending upon the simple molecular diffusion. Okay, when we are saying simple molecular diffusion, there are, as we know, there are three states of matter: gas, liquid, and solid. Gas is having the molecules that are far from each other, and then the liquid molecules are not so far but they have some distance, but the solid molecules are tightly packed with each other. Okay, like this. So what will happen, why we are saying the rate of mass transfer is high in the gases? Because the molecules are already far from each other. Okay, so they will quickly diffuse from one point to another point, or from one system to another system. Okay, they will take less time. So we are saying gases having the high rate of mass transfer as compared to liquid and the solid. Okay, so rate of mass transfer is high in gases and medium in liquids. Why? Because the liquid molecules are not so far from each other, so they may take some time to diffuse from one point to another point, or from one system to another system. They took some time. Okay, so that's why we are saying here the rate of mass transfer is medium. And when we are talking about the solids, so here, as we know, the structure, they have tightly packed structure. Okay, it takes so much time for the molecules to diffuse from this point to this point, from one system to another system, and hence we say in the solid the molecular diffusion is very very low, at very low rates, hence the mass transfer is low in the solid. Okay, so the molecular diffusion usually occurs, mass transfer due to molecular diffusion usually occurs in the laminar flow. Okay, and the mass and the turbulent diffusion, the turbulent diffusion usually occurs in the turbulent flow, or we call it as the eddy diffusion. Okay, so molecular diffusion is the simple random motion of the molecules. Okay, but the turbulent diffusion is due to the an external force that we are applying on the system. Like this is a liquid and we are putting another liquid. Okay, when we are leaving the system without applying any mechanical force, you will see after 1 day 2 day they are dissolving between each other, and the mass transfer is occurring. Okay, they are taking so much time. And and in another system, when we are putting in a stirrer, we are applying any mechanical force. Okay, it will create the turbulence. Okay, it will create the turbulence in the system, and the turbulence will increase the molecular motion, molecular velocities, like all these things, and hence the mass transfer will be more. So molecular will move from one point to another point very quickly in very less time, and we will get high mass transfer in less time. Okay, so the movement of molecules by means of an external force, which is most common is stirring, is called the molecular diffusion. Okay, the it's called the turbulent diffusion. Molecular diffusion is a slow process, while turbulent diffusion is a fast process. Okay, molecular diffusion occurs in the laminar flow, turbulent diffusion occurs in the turbulent flow, and the diffusion play an important role in the mass transfer processes or separation processes, which are like distillation, absorption, drying, liquid extraction, humidification, crystallization, and evaporation. Okay, these all process having some basics, which is the word diffusion. Okay, the diffusion describe all things that is happening in this system. Okay, so the base of mass transfer is the diffusion, and the diffusion is due to the random motion of molecules, or the diffusion may be by applying an external force which we call the turbulent diffusion. Usually in the industry we are dealing with turbulent diffusion, or we are dealing with the convective mass transfer or bulk mass transfer, like these terms. Okay, so this was all about the mass transfer and the rate of mass transfer. Thank you so much.